We said in Module 1 that there exist large systems that are distributed, which are so large that they are likely a collection of distributed systems, forming in reality a larger construct, a distributed ecosystem. It turns out such distributed ecosystems are much more common than we think. We will learn today about distributed ecosystems. Consider how science works today. We return to the worldview we introduced in Module 1. We highlight that in a large scientific project with tens to hundreds of research groups, it's not unlikely that data is collected in large volumes and with high velocity using all sorts of instruments that need coordination to collect the right information at the right time. And then this data get moved around for various kinds of processing in big data facilities, in artificial intelligence and especially machine learning infrastructure. Then the results get fed into high-performance computing and cloud computing data centers. Each of these facilities, parts of IT infrastructure and data centers, includes one or several distributed systems. All are put together, forming a powerful distributed ecosystem. Such large scientific projects are rare, but they drive human knowledge in their field. For example, in the Square Kilometer Array, the SKA project, the purpose is to acquire ever more detailed images of celestial objects, faster and with higher sensitivity, to understand better how the universe works. This project works as a large scientific collaboration with many countries contributing people, money, and for our purposes, their IT infrastructure, and all of this needs to be put together. With science and technology, there can be significant improvements in outcomes. The key technology here is similar in nature with a distributed system, but still different in kind. It is a distributed ecosystem interconnecting geo-distributed IT facilities of vastly different nature across the world. At each site, IoT sensors acting coordinated as a distributed system per site collect information. They do not need to be coordinated across sites. Sensors create large numbers of data streams, each of which must be transferred without data loss to where they can be processed. Processing of such data occurs in highly specialized IT facilities called science data processors, who act as very powerful filters to select only the data deemed relevant. At their volume and velocity of input, data cannot be saved entirely. So what is not selected by the filters likely gets lost forever. In other words, unless these data centers meet their service level agreements, the science data processors can limit the scientific advances that are made possible by the Square Kilometer Array. The outputs of the science data processors separately around the world is fed into a system of autonomous yet cooperative central processing facilities. Each central processing facility is also a data center, but these can be differently built and thus be better at different kinds of computing activities. The central processing facilities are autonomous IT infrastructure, contributed to the project by different countries, institutions, and sometimes even research groups. They are autonomous, meaning many central processing facilities can be added or removed whenever their operators, their owners, decide to do so. They are organized in tiers of capability and availability, and they are federated, meaning they can coordinate their operation to complete larger scientific tasks. The central processing facilities offer advanced processing capabilities to different scientists around the world. Hundreds of research teams can run their own models and analysis on parts of the data and sometimes across multiple data sets federated across multiple central processing facilities. Thus, these IT facilities must address vicissitude. That is, that challenging demands of many different kinds are imposed at arbitrary time on these systems. By composing the results of many different scientific tasks into workflows and later into workflows of workflows, and by reusing and reproducing them later, scientific teams around the world hope to collectively uncover scientific mysteries that pertain to the universe. All these are aspects of distributed ecosystems, which are the focus of this module.